Hello, welcome back. In this video, I'm going to be going over 3 ACT math questions. For all these problems, I recommend pausing the video and trying the problems yourself first before you see me solve them. Without wasting any time, let's get into it. Question 34 says, the first 4 terms of a sequence are shown in the table. The sequence is defined by a1 equals 2 and an equals an minus 1 plus parentheses n minus 1 parentheses closed squared for n greater than or equal to 2. What is the sixth term? A6 of this sequence. So my first instinct for this problem is, right, we have this recursive formula here, an equals an minus 1 plus parentheses n minus 1 parentheses closed squared, right? So to figure out the sixth term, let's just plug in 6 for n, right, into this recursive formula. So a6 equals n minus 1, so 6 minus 1, which is 5, plus 6 minus 1 squared, right? And you get a6 equals a5 plus 5 squared, which is 25, right? 6 minus 1 is 5, 5 squared is 25. But now, notice that in the table, it doesn't give us what a5 is, nor does it say it in the problem, right? So what we actually have to do is we need to use this formula to figure out a5. Because we're already given a4, right? And since it's an minus 1, we will be able to plug in a4 there. So let's find a5 first, okay? And then we can just plug a5 here, and then we can figure out what a6 is. a5 equals a4 plus 5 minus 1 squared. 5 minus 1 is 4. 4 squared is 16. So you have a4, and a4 is 16 as well. So you have a5 equals 32. And we can just plug 32 in, right, for a5 up here. And we get a6 equals 32 plus 25. So we get a6 equals 57, which matches answer choice G, right? So for this problem, just remember that you're going to have to use the recursive formula, and you're going to have to work backwards. What I mean by that is, in this case, we were trying to figure out what a6 is, right? But we didn't have a5, so we had to use this formula to figure out a5. We figured out our term, helped us figure out the sixth term. We figured out the fifth term, and that helped us figure out the sixth term. So for this problem, just remember that you're going to, if you see this type of problem again, you're going to just be working backwards. On to question 41, which says, given that 1 less than or equal to m less than or equal to 4, comma, 4 less than or equal to n less than or equal to 6, and 8 less than or equal to p less than or equal to 10, what is the greatest possible value for m over n times 1 over p? So first, let's just multiply these two. M over n times 1 over p, that's m and p, right? So we're basically trying to maximize m over np. So now, remember, for a fraction, if you want to maximize a fraction, the value of a fraction, you want to maximize the numerator, and you want to minimize the denominator. Why? Well, let's say you have 5 over 2, right? This is 2.5. But if I increase the numerator to like 500 over 2, this becomes 250, right? Increasing the numerator increases the value, right? Same logic. If I have, let's say, 5 over 5. That's 1, right? But I decrease the denominator to 1. I change it to 1. I get 5. Notice how if the denominator becomes smaller, the value becomes greater. So in this case, we want to pick the greatest value, pick the greatest number in this range for m, pick the smallest number in this range for n, and pick the smallest number in this range for p. So the biggest number for m we can pick is 4. And the smallest we can pick for n is 4. And the smallest we can pick for p is 8. So 4 over 4 times 8 is 32, which simplifies to 1 over 8, right? This matches answer choice D. On to the last question. Question 44, which says, the table gives values of f of x, g of x, and h of x for all positive integers x less than or equal to 5. Given h of f of g of a equals 1, where a is a positive integer less than or equal to 5, what is the value of a? So for this problem, what I would do is I would start from the outside, focusing on just h. So what I mean by that is, well, we know h of something, right? In this case, the something is f of g of a, right? That equals 1. Well, what is that something? H of what equals 1? H of 5 h of 2 equals 1, right? So that means h of 2 equals 1. This means that f of g of a, right? This has to equal 2, right? Because we know that h of 2 equals 1, so that means f of g of a has to equal 2, because they're interchangeable, right? So now we can just do the same thing again. F of something equals 2. What is that something? F of x, 2. When x is 1, f of 2. When x is 1, f of 1 equals 2. So that means g of a has to equal 1. And now to solve for a, we just have to see when g is equal to 1. G is equal to 1 when x is 5. So g of 5 equals 1. So that means a has to equal 5, right? So that means the answer to this question is J. So just remember, for this question, you have to start from the outside, break it into steps like this, and then you'll figure out your answer. I hope my explanations made sense, and thank you for watching.